This lesson deals with supplemental problem 10.4. You can find this problem in the course ebook in the Chapter 10 Supplemental Problems on page 4. Can you repeat supplemental problem 10.3 but now with beta F equal to 300? So if you look at the previous problem, our value of base current doesn't change. It's still 10 minus 0.7 over 390K, which is 23.8 microamps, which is greater than or equal to 0. Our collector current now is 300 times that value, and that's 7.14 milliamps. Then in that particular problem, we'd solve for the emitter collector voltage as 10 minus 2.2K times I sub C, but now I sub C is much bigger. It's 7.14 milliamps, and that makes this a negative voltage. So the base current is greater than or equal to 0, but V sub EC is not greater than V sub EC sat equal to 0.2. So it's not active. Since we have a base current, let's get saturation. So our model is the same structure as the previous one. We have a voltage source between the emitter and the base of V sub EB on. But now between the emitter and the collector, we don't have a current source, we have a voltage source of V sub EC sat, which was equal to 0.2 volts. Base current, our collector current, still trying to solve for the voltage V. If we go around this loop here, we just have voltage sources and things that have I sub B in it. The voltage across here is 390K times I sub B. The rise in voltage would be just that, rise in voltage of 0.7 and a drop of 10. Setting those equal to each other, the rise is equal to drop. We get the same equation we had previously of 10 minus 0.7 over 390K and still 23.8 microamps, which is greater than or equal to 0. Now with the collector current here, we're going to get a drop, which we called V, of 2.2K times I sub C. So that rise in voltage plus the rise of 0.2 has to equal 10. The rise in voltage is equal to drop. And solve for I sub C, it's going to be 10 minus 0.2 over 2.2K, and that's 4.45 milliamps. Now to be in saturation, base current needs to be greater than or equal to 0. The collector current needs to be greater than or equal to 0, but also their ratio has to be less than or equal to beta F. The ratio is 4.45 milliamps divided by 23.8 microamps, and that's 187. And that is less than 300, so the state is verified. And then lastly, what's the voltage V now? We could use that loop equation we just did. The rise in voltage is V, the rise in voltage is 0.2, and there's a drop of 10. And our value would be equal to 9.8 volts. And this is supplemental problem 10.4.